Hello and welcome to the third part of the repair series from the viewer that sent in 4 different mainboards. We had 2 different ASUS boards now, one Z490, one Z490 and 390. And now we have a Prime B450M-A Wi-Fi, also an ASUS board. And so this time we have AMD instead of Intel. And the viewer said he does not remember what was wrong with this. This was in storage for quite some time. So we will go into, I think we will instantly go over to plugging this board in with the CPU and seeing for the passive power consumption. And then just go from there, see what is up with this board. So we're going to be plugging in a 2200G in here. And let's see now. We get our 24 pin and let's turn our power. And we have 170 milliamps, which is normal with having LEDs. And yeah, let's see if we have a reaction to the power button then. So let's get a speaker and a power button onto here. So let's see. Pressing the power button. We do have a reaction to the power button. 1.2 amps. There's no LED indications of anything. Okay, 1.2 amps looks fine because there's no memory in it right now. So it's probably just complaining about missing RAM. So let's see this again. So memory in there and also getting a postcard. So DDR postcard. Let's see. This is an ASUS board. They have a pin header that is called COM debug. It is right this one. It's called COM debug, and there's the first pin in the bottom left, shown by the gray rectangle. What you can do is these postcards. These can be plugged into there with minding the orientation, and then you also get postcodes from there. So we have 2 different postcodes now. We have from there this and that. And let's see now. We're going to turn it on, 150 milliamps, and let's see now. Any postcodes? No postcodes here, and also no postcodes there. So there's something missing as far as it seems, because we do not have initialization of this board. We do not go into the postcodes. The CPU is getting a little bit warm, but we're stuck on 1.3 amps. Let's see. Let's reseat the RAM and get it in a different position and see if that can help. So let's try this again with RAM in a different position, but we have the same behavior. Okay, first the things I would think about is either the BIOS might have a problem, or what else could be is that our processor isn't recognized. I'm not too sure if 2200G is recognized by B550, because there are some B550 boards that don't like older than 3000 generation. So let's take something newer. This is a 3100, and let's see if this 3100 is recognized in here. So turning it on, 1.4 amps, but no postcodes yet again. So that means that that it wasn't the processor's fault. We will now have to check some voltages because we're obviously missing something. It doesn't like something. But before we do that, let's go and do a BIOS reset. So turning off the power consumption and going to hit the clear CMOS header. And after having held that clear CMOS header, let's now hit the power button again and same behavior. So that also didn't help. So let's get the DDR voltage tester in here, because we might have some missing DDR voltages. So let's see for that. So let's see. DDR tester. We have all voltages. So all DDR voltages are also present. Okay. So currently we have the issue that our BIOS isn't initializing. And I would expect 2 different things. Either the BIOS is wrong, or we do have problems with knocked off components somewhere, around the socket, around the SIO, or similar things, or the TPU chip of this board. So I will now be going over to the microscope, and I will be checking some areas that are prone to damage. And let's see if I can find anything, especially also the backside, if that is why our BIOS isn't initializing. And if that doesn't work, we are going to go over to flash the BIOS via the header that is on here. And yeah, let's go from there. So I can already see that the BIOS has been flashed because this chip was off of this board. So we will definitely have to reflash this BIOS. I will also have to check if the orientation is right and if there's not a missing component right at the bottom right here, and if this component is still fine. So I wasn't able to find any knocked off components or any damage. I just glanced over it. I wasn't too thorough, but we'll have to go into board view because of this BIOS chip. The soldering isn't the greatest, but it looks fine. But we might need to reflow it. Yeah, we will have to check for these passives at the top right and at the lower part of this BIOS chip, and we will also have to flash the BIOS, and we will probably be using the TPM header. But let's head into a board view and see for this area. So we're now in the board view, and let's see. So this is missing. This is not assembled. This is supposed to be 10k ohm, and this one is also not assembled. So all of that seems fine, whatever was supposed to be here. We might need to check if these are present. I'm not sure if these were knocked off or not. This is for the SPI, the 1.8 volts. So bottom right is pin 8, so top one has to be pin 1. Okay. Well, and this is a 1.8 volt chip. So let's go under the microscope and check once more for these components right here, and to check this 10k ohm resistor. And then we will go over into flashing the BIOS. So let's see, these two components are there, and that 10k ohm resistor seems to be there. It might not be properly soldered, but we can check that. We will need just the multimeter and see if 1.8 volts reaches the chip there. So let's turn the board on and check for voltage now. Is the board on? The board is on 1.8 volts and 1.8 volts. And 1.8 volts on the chip. So that is present. So that is not our problem. Okay, so let's go over into flashing the BIOS then. Let's see if I have a way to connect to this TPM header. I think I do. So what I will be using is this monstrosity of a cable. This has a JTAG connector on its end right there. If I could get some focus off of my camera. This is a JTAG connector, and on the other side it has a breakout board with an 8-pin, just a lot of hot glue. And this is what I've made to connect to the TPM header that is right next to the chip. So let's go into the microscope and I will show you. So what I do is I have pin 1 also marked, as you can see by the silver paint on the connector. This is my pin 1. That is right there. And what I do now is I can just connect this onto there. And now I have a way of flashing the BIOS in circuit. So I once made this cable that is now connected to here, to the BIOS chip, and now I will be able to flash the BIOS without taking the BIOS chip off. And this will also verify if the soldering is correct. If the soldering of this BIOS chip would be bad, I wouldn't get any connection through the pin header, and that would also tell me that the BIOS chip needs resoldering. But let's now go to the PC and do some BIOS flashing. So now on our BIOS flasher software, let's connect it and let's see if it can recognize the chip. We're going for 1.8 volts, read identification, too much current. So there must be something wrong with the way that stuff is connected. and there's too high power consumption as far as it seems, with 1.8 volts. So we might need to resolder this chip because we don't have a great connection, or something is overdrawing. Let's also check if the orientation is right of the chip. And yeah, let's go from there. Let's go under the microscope once more then. So the orientation of the chip seems fine because we do have the dot in the top right. So that seems to be okay, but there has to be something wrong with the soldering here because we get too much power draw out of the chip. So what we're going to do, we're going to be protecting these two, and we're going to be desoldering the chip. What I will be using is aluminum tape. So this is the stuff that I use. So now we have it protected right there and right there. And now we will be able to solder this chip. So let's see. Let's get some fresh flux onto both sides. And I will be taking my adapter board that I use for soldering on chips, so that we can plug them in also. So let's get hot air into here. Let's get my tweezers. And a little bit awkward, but you will be able to manage. So let's see. I don't think it's soldered on properly. Yeah, that doesn't look properly soldered. I will have to resolder this once more. But this is how it's going to be looking like where our chip is connected. So now on our BIOS programmer, with now the board in, and as you can see, it read the identification and now has the right chip. So the chip is definitely working. So let's read the memory to buffer. And what we need to do is we need to prepare the right BIOS for ASUS boards. So now we are on the ASUS website. We're going to hit on support. And what we do, we go to drivers, to BIOS. And let's now see, we have a BIOS from the 4th of, what is this? Whatever this is the, yeah, the 4th of November 2024. So let's flash that. So we're going to download that. And let's now head to our folders. So now we have our BIOS. We're going to extract it. And we need this cap file. And we need to edit this cap file because this is not the right file to flash. So we need something that is called UEFI tool. We're going to open this file in here. We're going to just drag it in. We need the UEFI image right here. So this is a capsule. This UEFI image we're going to go extract as is, and we're going to put it in this folder, and now we have the right BIOS file that we can flash. So now in the BIOS programmer, there's a lot of content here. Looks weird, the content that is on this chip, to be honest. Okay, let's open up the image that we've just extracted, and this looks completely different. Okay, so this might be very good for us. Okay, so we have completely different contents. So we're going to write buffer to memory. This is first going to be erasing the chip, then it's going to be programming, and then verifying. So let's do that and hope for the best. So currently the board is verifying after it has flashed, and now the verification is done. So I was able to do a verification, another one with the buffer. So now let's take this chip off of the adapter and put it on our board. So what I want to do is I want to wick off the solder that is on here, whatever that solder is, because I just want to have my ladle soldered onto here. So I can just solder with that. So getting flux on there, and then taking our soldering iron, and now we can wick it all off properly. So, and now adding some of our leaded solder, just some more flux again. And now some more leaded solder. So we now have enough leaded solder. Let's just go get a bit on the ground pad. And what I also want to do, no, we're just going to leave it like that. Let's now we now need to desolder it from our adapter board. And then it's going to go into there. So let me blast it off of the adapter board and I will instantly be putting it on there. And just like before, the previous flux that on here stinks so badly, holy moly. So let's see. I think the chip is in place. Should be fine now. Now let's get the aluminum foil off, and just so you can see, the headers are mostly fine. They had damage before from soldering, and we didn't really make that worse. Maybe a little bit on the CPU, on this fan header. So let's clean up the area as long as it's still hot, because it cleans up a lot easier then. Also get that awful smelling flux off of here. So now the BIOS chip is on there. I'm now very interested in how this board will react. So let's get the, what is this? This is the 2200G in here. Let's get the postcard on here, and also this PCIe postcard. Let's put in the power. Let's flip the power switch. And let's hit the power button. And still nothing, huh? Still the same behavior. Still 1.3 amps of power consumption. Nothing has changed. Let's see for a different CPU. And with the different CPU, we probably won't have any change. Yeah, no change with the different CPU. What I want to do, I want to test if I can get a connection now via the TPM header, if the soldering is okay on this board. So let me try that. So it took me some time, but I figured out why I had problems before. This is an TPM and not an SPI header. It's a little bit different on this Asus board. Asus seem to have different standards for multiple boards, and on this board it seems like that they have shifted the actual SPI by these 4 pins. So these 4 pins are actually nothing that I need for flashing. Only when you start later then off of the 6th pin you actually get connections to the actual chip, as you can see here. So only with the lower ones. So I had to shift my connector from these 4 down to connect to all of these, and then my programmer started to react, and I was actually able to flash the BIOS. And flashing the BIOS actually got us further. Let me show you. So let me show you how much further we've gotten. So connecting all of the power supplies and getting a processor into here. Let's take this 3000G for example. Let's put a speaker on here, a power button. Let's put a cooler on here. Now we have the passive power consumption, as you can see. And now listen to this. I hope you can hear that. Those are beeps for missing RAM. Missing RAM it is. We turn it off. We're going to be putting on our DDR4 post analyzer card. And we're going to be using a DIMM of RAM. And have a look now right there. And turning it on. We get postcodes running. 6E is the last one that we get, I think. And then to AF. Which should mean that this board is on and has posted, but we do not get a post beep. And we also don't have a picture out of this. Let me restart this. Yeah, the power consumption jumping again. But we get no picture. And what we also don't get is anything on USB. Which means when I connect a USB, you have my keyboard and there's no numlock indication. Nothing. But one thing that I can show you what we have. Let's take this off and put my PCIe tester on here. Have a look here. And if we now turn this on, you can see constantly that red LED there. That means PCIe reset is stuck permanently on this board. So the SIO has the function to take off reset when all of the voltages are okay on the board and when the board is ready to start up. But I wasn't able to find out why. I kid you not, the last 3 days this mainboard has been haunting me. I cannot figure it out. I've asked in multiple different chats and I've studied schematics up and down and I couldn't figure it out. I do not know what is wrong with this. As far as I know, the SIO, what it does, it takes power good signals and it takes also the voltages like 5 volts, 12 volts and similar, and VCore for example, and takes them all in. And then there's also another signal that's called O power OK, which is like all power OK, and then takes off reset at some point. But this chip does just not do it. I've looked through the schematic and the actual board view for this board so much, and I've looked up and down for so many things, but I just couldn't figure out why this SIO wouldn't take off reset. A single thing that I found out is that this PCH is not getting hot at all. Like there's no heat signature of it whatsoever. I can show you that. So now having a good look at my phone, let's get rid of the overhead light so it's easier to see. So let's, as far as we can see right now, only the CPU was getting hot, nothing else. And let's see now, turning it on, power consumption, and then turning it on. We have multiple things getting hot, just normal for a normal board to start up. The CPU is getting very hot, so hot that we cannot touch it. But what is not getting hot is the PCH. It's not getting hot at all, as you can see. So no heat signature at all from the PCH. So what I would say is that probably the PCH has a problem. But I cannot figure out what is wrong with them. There's multiple voltages that need to be present for the PCH to get recognized, or the PCH to start up, and I can show you a few of those. I still remember them. So let's see. We're going to turn the board on, and I can show you some voltages. Let's see, let's zoom down a little bit here. So the board is on, as you can see by the power consumption. Looking at this voltage right here, 1.8 volts, this is for the PCH. There's also this, which is 2.5 volts that the PCH needs. Then there's this, which is 105 volts that the PCH needs. And the PCH doesn't start up. There's no heat, nothing for it. The only thing that would be able to check is like if the clock generation is running. So let's do that next. So currently we're looking at the quads at the top right there, and we have 33 kilohertz. You cannot see that, but that is the waveform. I don't have a small oscilloscope. I only have the big 4-channel one for wriggle, which is great, but it doesn't fit in frame very well. Let's see now. Do we have any oscillation on the one for the PCH. Let's see. Let's turn it on and see if that is needed for the oscillation to start. There's basically nothing there. There's a little bit of noise. There's a DC offset just here, but nothing else. Let's see here. And there's also nothing there. So we do not get any oscillation from this quartz right there. So let's get into a board view and see if there's any more oscillation for the PCH, but I believe that is the only one. So let's see. We have this oscillator. This should be a 25 megahertz one. And as you can see, this goes to, where is it, here? And then from here, goes through 0 ohm resistor and then goes into the PCH. And we do not get any oscillation on this quartz right here. For example, this is the other one that we had. This is supposed to be 32.7 kilohertz one. We instantly had that. So we should see on one of these two, probably, let's see, is this also 0 ohms going into there? Yeah. So on these 0 ohm resistors, we should see oscillation on either this one or that top one. And both of them are going into the PCH. And we do not have that. Let's see, is there any other one? Can't see one on the backside either. So I'm pretty sure our board isn't running because our PCH isn't running. And one of the indication is that our clock crystal isn't running. But I cannot figure out why this PCH wouldn't run. What does this thing need in order to turn on? So I've been following this power sequence for AM4. And you can see here PCH power. And in the S0 state that we want, all of these powers need to be high. This is 105, 2.5, 105. This is one is standby, one is the actual. And then there's also 3.3. There's also 1.8 volts, which we do have. And if we go into this power sequence, we can see there's PCIe reset. And PCIe reset in S0 is supposed to be high, and it goes high. I can show you this signal in the board view. Let's go into the board view. On the PCH, it comes into this dual AND gate. There's two inputs. This AND gate, this is the logical AND gate. It has two inputs, pin 1 and pin 2. PCIe reset lines, as you can see. These both go high, and then its output, which is this one, goes high as well. And we also do have that. So I'm pretty sure something around our PCH is wrong, but I just can't figure out for the life of me what is. A big part of this is that a lot of signals related to that are connected to the socket, and I feel like there's still something wrong with the socket. The another thing is, all of these passive components down here are really important for startup and similar things. But the problem is basically every one of these components has been reworked, and there's just so many areas that have so much flux on them, and it's just, I guess that there's still somewhere a missing component, but it's just not visible because it has been reworked all over the place. Let me go under the microscope and show you. So now we see the microscope view, and as you can see that all of these components look like they have been worked on before, they have been reworked. I've cleaned up this place a lot already, but there's still a lot of residue everywhere where you can see it. Like, this board has been through a lot, and this is the big problem with previous repair attempts, that there's just been so much work done to these that I don't even know what the original problem is and where to start from. And additionally to that, often they get bought on eBay for faulty, where you don't know if they already have been tried to repair, and then the viewer gets it, and then I get it, and it's just a rabbit hole, sadly. The area around the PCH itself looks okay. Like that, it doesn't look like there's been a lot of reworking done here, but the biggest problem is just the area connected to the processor. And what I also want to show you is that also the capacitors in between here also look like this socket has been reworked. So this is the third board now that also looks like it had its socket replacement. This one has good connections on the DDR and on the PCIe, as far as I can tell, but I still think that there's something wrong with the socket. That our socket isn't properly soldered, or some connection to the processor isn't being given. I've tried with different processors, I've tried to cleaning this out, but yeah, it just wouldn't want to work. And this is where I have to leave this mainboard, because I've spent just in hours, I think I've spent 6 or 7 hours trying to figure this board out. It's been a rabbit hole for me. I've learned a lot, definitely, about power sequencing and how AM4 works, but not getting to a result is really frustrating. And at some point, you just have to cut it and say, yeah, this is going nowhere, especially because this is a previous repair attempt, and as far as it seems, the socket has already been tried to replace. So we need to call it quits on this board, even though it really sucks and it really devastates me, especially because the board goes so far with the power sequencing. We go as far as having checked RAM and going over RAM, and then we should be going to VGA, but it just does not want to get further than that. It really devastates me, but that's all I can do, sadly, for this board right now. So, now we are at the last mainboard for this Joblot. This is a Strix B450-I gaming, and this board is a nemesis of mine. I've had 3, I think, of these. I was able to repair not a single one. These boards just wreck me. As you can see, we have passive power consumption, 160 milliamps. We have backlights. And this board is a mess. There's so much soldering at so many different places. Like the whole VRM area around the PWM controller. Around the SIO has been a lot of soldering. The BIOS has been flashed. And I've actually already worked on this board off camera. Or I've tried to make a video on this, but it just led nowhere. One interesting thing, there's the usual SOP8 BIOS chip on here that we know. But the board actually has a ground pad under that, which is not connected. So this BIOS chip might have been replaced already, but it is the correct voltage and it also is the correct size. And I was able to confirm flash a different BIOS onto there. So that seems to be not the problem. What else have I done? I've tried to look around this board for broken components, but there's just been so much soldering that I really couldn't tell when something was replaced or not, or when there was something missing or not. There was a single resistor that I found on the backside. There was a 250 ohm resistor that was missing. That was responsible for VDDQ. And that now is present and that now works. But the board still doesn't want to turn on. And it has the exact same fault that all of the other boards had that I was working on for these. Missing SoC and missing vCore. So you have a single SoC line up there. This is for the logic of the processor. And then you have the vCore of the processor. This is just an auxiliary 1.8 volts that is here. Also for the processor, as far as I know. And yeah, vCore just does not want to turn on. This board starts up, but it hangs up upon reading the BIOS and starting the processor. I can show you that. Look at the power consumption, 160 milliamps. I press the power button. We get 500 milliamps almost. And the board doesn't do anything. There's debug LEDs at the top right there, and it doesn't load anything. This board is just stuck because SoC isn't running and vCore isn't running. The PWM controller has already been replaced by the viewer. And I've tried to resolder it just to be sure that it's soldered properly, but no change. And I've looked for the VDD and the VIN, or however you want to call it, for this the PWM controller, and it is there. What I've also checked is the enable signal. The enable signal is good. But what isn't there, and also the power good signal coming out of the thing is good. And also proc hot is present. But I just can't get SoC and vCore. And I just don't know why. I've tried searching this board high and low for missing components knocked off, but you just can't tell. There's just soldering and flux everywhere. It's just, you cannot tell if there was a component ever there or not. Yeah, this just throws me off so much. And the other thing is, Asus has TPU chips, they are called. They are responsible also for looking around the system. This is this chip right there. And this chip has its own BIOS also, or its own programming. And these chips are a big mystery still for me. They even stand higher above the SIO. So they regulate each other, and if something with this TPU chip isn't right, all of the other functions, especially around the ITE chip, the SIO, won't work then. And this is my suspect, that something in this area is wrong. But as you can see by how shiny it is, there's been rework done all over the spot, even though I've cleaned it multiple times already. If you see here, there's just a lot of flux spots all over the board. And I just can't figure this board out, sadly. I've tried a lot and I've spent some time on it, and I'm just like, at some point, these previous repair attempts are sadly just rabbit holes where you go down. As more technicians have looked at the board and tried things, the worse it gets, especially if you don't have a back history on this. I do not know what the previous owner, the viewer, or the previous owner before him has tried to this board. I don't know how this board died, what has happened to it. So the probability of fixing this, the more people looking at this, always goes lower. So I wouldn't recommend ever taking in boards that are previous repair attempts, because the chance of fixing them is just so much lower, sadly. What I want to show to you as well, currently we have 4100 in here, and if we now turn off the board, if we now take this out and put, for example, a 3000G in here that is supported, and we now turn it on, we currently have also a reaction to the power button. But just moments ago, I've tried that and I didn't have a reaction to the power button, because that is what the owner actually said to me, that he didn't have any reaction to the power button when trying this. Let's see if I can replicate it now with different processors. Yeah, but now we have reaction to the power button, okay. But this leads me to believe that also something with the socket isn't right, because depending on that, the board starts or does not start. Let's see for the connections on the between the processor and the PCIe, for example. So looking at this PCIe slot is fine. There's all of the LEDs here. So that is not a problem. Let's look next at the DDR. And we can see, let me turn off the lights. All of these are also present that should be present. So DDR is also not a problem. Then let's have a look at the socket with the socket tester. So now having a socket tester in here, it is faint. Let me turn off the lights once more and go further down. All of these are lit up. It looks like the other ones aren't, but they are dim and all of them are lit up. So the socket seems fine, but it's really hard to tell, because cleaning out the socket and plugging it in multiple times just changed if it reacts to the power button or not. And yeah. Also, let me show you when we have a processor in here. Let's go with the DDR voltage tester. If we now supply power and turn this board on, and now if we get focus, we can see SPD is present, VPP is present, VDD, VTT, RCA, all of these are present. So DDR voltages are also all there. Especially VTT is important for the processor to turn on, because often VTT is used as an enable signal for vCore. So that is also there and isn't a problem. So sadly, this is the reality of previous repair attempts, that you just at a loss sometimes. I'm sure if you would be a better technician than I am, you could repair these boards that I've now not been able. Because if we do a quick recap, the first board turned on, missing channels on B1 and B2 for memory, but it was turning on. It worked, and there needs to be replaced either the socket as a whole or 2 pins in the socket. Better would be the whole socket. The second board, the Z390, had also needed a new socket because the socket wasn't soldered on properly. We were able to figure that out. The third board probably also has a socket problem. That was the MSI board that we looked at in this video, where the PCH wasn't reacting, where the PCH didn't have any oscillation on its quartz or crystal. And this board right here had previous repair attempts also. Yeah, I think it wasn't an MSI board, it was also an Asus board. The Asus B550, the last one that we looked at, and this one, I think they have missing components somewhere, but I just cannot tell where. Because so many passive components have been either replaced or soldered on the spot, and I just cannot tell. So much flux everywhere. And also the PWM controller of an unknown source. And I don't even know if this PWM controller needs to be programmed or not. I do not know that. If this has firmware on it in order to work. I don't think it does, but it might. And also the TPU chip. No idea in what condition this is. So this board is just yet another rabbit hole where I cannot get into it and knowing what is supposed to be here and how it should work. So sadly, the repair quota of these 4 boards was just awful, and I've spent so much time. I dug into them really deeply, but I just wasn't able to get any further with them. I'm really sorry for that. Sorry for the viewer. I put a lot of effort into here, but I just couldn't do it. Very sorry. And this is just the sad reality of repairing, especially previous repair attempts. And there's just so many things that are not documented on my main boards, where I just get stuck at a point where almost no one knows the answer for. And yeah, I even have documentation, especially for the B550. I have an Asus B550 schematic where I was able to look into so many different things, where I checked so many things over, and I just couldn't get anything out of that. Just like for this board, I also have a board view, but that didn't help at all. I would have to go over every single passive component and needing to look after every single resistor, trying to figure out if the actual value of it is okay and if it's properly sorted. And that you cannot expect that from me to do that for this board. Yeah, so if you're fixing mainboards, I would heavily advise you to not take previous repair attempts. If you have a lot of time, go for it. Take them. You can learn a lot from them, digging deep into them. But yeah, I have a big repair queue. I get a lot of mainboards, and I want to invest the time, and I did invest the time. But at some point, you just have to call it quits, because I got really frustrated with these repairs, and I just had to take time off because it was just not getting anywhere for me. And I'm really sad for not being able to help this viewer better out with these boards, but that's just the sad reality. I have a big shelf myself of mainboards that I couldn't fix and I couldn't get further, but we all learn and we all get further with that. And the biggest thing is to take out of these boards is that you've learned something, that you've tried it, and you've tried to get further and further with them. This is the biggest thing. If you're not able to fix a board, at least try to learn something out of them and get something out of them. This is what I have taken especially out of these repairs, where I learned, okay, check the socket has so much to do with the power up of a board. So many signals come out of the processor, especially on AM4, in order for the whole board to work. So many enable signals, so many clock generations even happen on the CPU itself. So that is one of the biggest things I learned in all of these repairs, and I hope you still enjoyed them and still could learn something from all of that. So this was Mainboard Medics. Sorry for not being able to fix boards here, but I still hope you enjoyed it. Thank you very much for watching. All of my tools are linked in the video description. Thank you very much and goodbye.